Hi there, welcome to Outcome SS 5.6. I am here with my dog Blue, so if you hear panting, it's her. It's not me, I swear. Alright, so we're going to identify and sort quadrilaterals, including certain types of quadrilaterals: rectangles, squares, trapezoids, parallelograms, and rhombuses. Okay, so the word quadrilateral, let's just talk about that for a second. A quad, how many wheels does your quad have? Well, it has 4. So anything that says quad means 4. So lateral means that there's a side to it or an edge to it. So we're talking about 4-sided shapes. So all of these shapes that are listed here have 4 sides: rectangles, squares, trapezoids, parallelograms, and rhombuses. Okay, so once you know what these shapes are all called, then the indicators down at the bottom say that you have to identify and provide examples of those shapes that are found around the house, compare and identify common attributes. And we'll talk about attributes in a minute. I have a slide for that. And then you have to analyze a set that has been sorted and determine where a new one would fit in that set. And we're going to do that with a Venn diagram, and I will show you what that is. And then describe orally or in writing the attributes of different quadrilaterals. So you might tell me what kind of angles they have, if they have parallel sides or perpendicular sides, if they are congruent, if they have congruent angles or congruent sides. And then lastly, create a model to illustrate the relationships between different quadrilaterals. So I've got a model on one of the Venn diagrams, so you could use that as one of your diagrams that you draw in your journal. So on to the next slide. Okay, so here's 2 Venn diagrams. Now a Venn diagram is just circles that intersect. Remember that word intersect? So right there, those 2 circles meet up. And so the first Venn diagram here shows that everything in the red circle has sides that are congruent, and congruent means same. Okay, so that rhombus has all of its sides are the same length. Now, if I thought printing with my mouse was difficult before, now it's really difficult because I'm holding a Pomeranian. Anyways, all the stuff in the green circle says that the angles have to be congruent. And so let's look at this orange rhombus. This angle is kind of small. I would say about 45 degrees. This angle is larger than 90. Okay, I'm putting the dog down. Hi, doggy. There you go. Yeah. Okay, so that angle is larger than 90. So those 2 angles are not the same size. They are not congruent. So we could not put the rhombus over here because this one says all angles have to be exactly the same. Make sense? So look at the yellow rectangle. It has all of its angles are 90 degrees. But it can't go in the red circle because this side length is much longer than this side length. And as it says for the orange circle or the red circle, all the sides have to be the same size to belong over there. So then the square comes along, and it is the type of quadrilateral that has both. Not only does it have 90-degree angles, so all of its angles are congruent, it also has sides that are exactly the same. All 4 sides are exactly the same size. So when you're talking about attributes of quadrilaterals, you can talk about their angle measurements, you can talk about their side lengths, you can talk about what is congruent and what is not. So let's look at the larger Venn diagram down here. Now this says polygons. Now poly means many, and in this word we're talking about a many-sided figure. And so we all know that an octagon has 8 sides, right? A pentagon down here has 5. A triangle has 3, right? So in the larger set of flat 2-dimensional shapes, polygons kind of is the broad umbrella that all the shapes fit under, because you can have any number of shapes to be a polygon, or any number of sides to be a polygon. Now, there's a special set of polygons in the red circle, that's quadrilaterals. Now remember what quads have? Quads have to have 4. So everybody that's in this red circle has 4 sides. Parallelograms have 4 sides, rectangles have 4 sides, squares, rhombuses, and trapezoids, all 4 sides. But a trapezoid is not a parallelogram, because a trapezoid is shaped like this. Okay? And so technically this side is parallel with this side. But these two are not parallel, because if we extended those lines, eventually they would run into each other, right? So these lines are not parallel. So we cannot include it in the parallelogram circle. All right, let's look at rectangles. Rectangles and rhombuses we've explained up here. So everything that is in the purple and yellow circles in the big diagram is explained up in the smaller one. Okay, let's move on to the next slide. Here are all those shapes. And if you look, they've kind of got the attributes labeled in the colors. So first of all, this one here is just called an irregular quadrilateral. Quad meaning it has 4 sides, but irregular means that this angle is not the same as this one, which is definitely different from this one, which is different from this one. None of those things are the same. We'll give them all an X because they do not match, they're not congruent. This one is called a trapezium, which means it has some attributes of a trapezoid, but not quite. So one side is symmetrical, this side is symmetrical, but this side is not. Okay, then we move on to, this is basically a trapezoid. Okay, and you can see over here it was called a trapezoid too, but just a couple of different names. So a trapezoid, it has the blue angles are the same and the red angles are the same. The black lines, the top and the bottom, are parallel, but the red ones are not parallel. The sides are not parallel. The red ones, though, are congruent. They're the same length, and the black sides are not congruent. The black are not the same length. So if you had to describe this with words, we would be able to talk about what's congruent, what's not, what the angles look like. Are they the same? Are they congruent? Moving on to the parallelogram. The blue lines are parallel, the red lines are parallel. The opposite angles, see that? Those are congruent because they're both marked blue, meaning they both match. In the kite, the one set of opposite angles is congruent, but the blue angle down here is not the same as this red angle up here. Okay, and the two top lines, the two red lines, are congruent. They're the same length, and the two blue lines are the same length. If it was a perfect rhombus, let's change colors here. Let's go purple. If it was a perfect rhombus, that would mean that all of the sides are congruent, just like a square, except a rhombus is kind of like a squished square. Somebody has sat on it. And so the red angles match, but the blue ones are no longer 90. They've been squished, and now the red angles are bigger. In a rectangle, it has 2 sets of parallel lines. The red lines are parallel, and the blue lines are parallel. They're not all congruent. They're not of the same size. The red lines are the same size as each other, and the blue lines are the same size as each other, but they are not the same size between the red and blue. Okay, so they have 2 separate sets of congruent lines. They have all 90-degree angles. Every corner is 90 degrees. And then when we talk about a square, it has all the sides are congruent, meaning this side is equal to this side, which is equal to this side. They're all congruent. And all of the angles are 90 degrees. and it has two sets of parallel lines.